So in this problems, we're going to do problem 419 to get some practice in terms of multiplication law. So this is problem 419. First, let's summarize this problem. Um, the first piece of information that you get is that the um, number of American adult who has who's stockholder. So we have the PS equal to 0.43, and then it, it says out of 75% of the American stockholder have college education. So let's go C to be the event of somebody who has college educations. Then um, the piece of information translate to um, the conditional probability given that a person is a stockholder, then the probability that um, they have a college education, so that's be P of C given S is 75%. And finally, we have the probability of somebody who has a college education, that's 37%. So let's go to the first part. We need to find the probability of an American chosen at random is a stockholder and have a college education. So that's probability of S intersect C. Now we can you see that we have P of C given S, and we can use that to compute the intersections probability. So that would be P of C given S times PS. That's the formula for the multiplication law, and that's 0.75 times 0.43, and that is 0.3225. So that's the first part. And in part B, we want to find the probability that somebody that the person chosen at random um, do not have stock. So here, let's look at the complements of the S event, which is stockholder. So S prime would means that the event of somebody do not have stock. So P of S prime is 1 minus P of S, which is 0.43, and that gives us 0.57. So that's the probability that a person does not have stock. So here in part B, we need to find P of S prime intersect C, and this is similar to the problem that we did in addition laws, right? So let's draw a Venn diagram again. Um, First, we draw the circle for event S, and then we draw the circle for event C. Uh, the complement of S, which is everything outside S, right? So I'm going to color them blue here, right? So everything outside S. And let's look at S intersect C, right? So S prime intersect, I'm sorry. So that is where the blue part intersect with C, and that would be the red part. And you see that is right inside C, right? Except for there's a little piece there that we haven't account for. And what is that piece? Um, that's claret green, and that piece is actually S intersect C, right? That's what we found in part A. So here we can find probability of S prime intersect C is P of C, which is a circle, right, minus probability of S intersect C, which is the green part. So that's 0.37 minus 0.3225, the probability from the part A, and that's 0.0475. So similarly to part B, you want to find the probability of S intersect C prime, and with the same approach, right? So that's going to be P of S minus P of S intersect C equal to 0.43 minus 0.32225, and that is 0.1075. In part D, we can use the same trick, right? We need to find probability of S prime intersect C prime. And that's going to be P of S prime, right, minus P of S prime intersect C, which is from part B. And that is 0.57 minus 0.0475. That's 0.5225.